Joe in Chicago writes, Paul, what's your take on replacing op-amps and preamps and DACs with third-party discrete op-amps that claim improved performance? Is there something to this? And if so, why don't OEMs install them in the first place? Well, I'll tell you, they do. And it's just not so common knowledge. So let's talk briefly about what it is he's referring to. An op-amp, an operational amplifier, is basically a topology of an amplifier that consists of a differential pair, a gain stage, and an output buffer. Okay, you got those, how many things? 1, 2, 3. So it's usually represented by a little triangle, and we have a plus input, a minus input, and an output, all right? And that can be built with discrete transistors, or you can just buy it off the shelf as a chip. And there are bazillions of chips available. And we built our very first phono preamplifier on one of those chips. That was the venerable 709C op-amp, Bob Wildler design. Fabulous product. It was really, an eye-opening revelation how good that chip sounded. But in subsequent models of our phono preamp, this is back in the early 70s, maybe the mid to late 70s, we switched over to discrete. Now, all that means is the circuitry inside of the chip is replicated to some degree outside of a chip with discrete parts, with separate transistors, separate resistors, separate capacitors. Where normally on a chip, they're all put onto a single piece of silicon. Now we have these multiple pieces of silicon in their own little packages with their own little legs, and even today, that was back then. Today we use surface mount with little things you can't even see that don't have any legs. They just have little pads and they get soldered down there. But it's the same thing, right? The silicon die, the part that actually does the work, is identical to what we used way back when. They just were in different packages. So the advantage of a chip, or a discrete over a chip, is that for a specific circuit, for a specific purpose, we can custom design our own magic brew, right? So here's an example. In an amplifier, in a preamplifier, let's say, we want to have a certain level of sound. Well, if I use a chip op-amp, especially the ones way back when, they had huge amounts of open loop gain, which means the amount of, you put something in, you get something bigger out. That gain was so big that if you didn't wrap feedback around it, it wouldn't even work, right? I mean, we're talking hundreds of thousands of dB of gain. I mean, not dB, but we use a numeric value. So like if you have a gain of 1,000, you put 1 volt in, you get 1,000 volts out, you put 0.1 in, that kind of thing. So this would be like 100,000, huge amount. And if we didn't wrap feedback around it, it wouldn't even work. That has its advantages for some circuits, but it's not great for audio. So audio likes to have low open loop gain that the circuit will work without feedback, and then you put a judicious amount of feedback around it, life gets good. You can't typically do that in chips. Why? Well, because they just don't make chips like that. They could copy the discrete designs that we do, and it would be even better because chips have the advantage of being on a single die. So any kind of temperature fluctuations, everything moves together. Where in a discrete circuit, if something changes, this package, that package, they don't all move together. So it would be advantageous to have a chip. All right, so to his question, you can buy these little boards that have a discrete op-amp on them, and they're made so that they plug right into where an 8-pin dip A dip is the way we refer to these chips of yore, and they had 8 legs. DIP stands for dual inline package, just to be a nerd. And there were 4 and 4, and it would pop right in. So you can pop that sucker out if it's in a socket or unsolder it, and you can put in this discrete circuit. And depending on who designed it, I would imagine it probably does sound better. So, long-winded answer. Hope that helps. Thanks for the question.